Okay, Natalia, I think we can start the session, no?
Okay.
Okay. No, there is another presenter that sent me the presentation earlier this morning. So, welcome to this new session of the general track, and today we have 4 papers. I would like to start checking for the presenters. In particular, is there anyone for the first paper of this session? First of all, one of the authors of a comparative analysis of demand forecasting method. No one is presenting this paper. Okay, maybe we can skip this. And is there any presenter for the second paper? The second paper, classification of carcass fatness degree. Essentially, because Natalia, I can see the names of some of the people attending the session, but there are others that are just named as fellow GITSNers, but it's quite difficult to understand.
No, I don't know.
This is why I'm trying. The third presenter, I think the third presenter, you told me that the third presenter is present.
Yes, here I am for skin cancer classification.
Okay. And the last one sent me the presentation, so hopefully it should be here. Is the last presenter Vladimir Shakov in the room? Quite strange, because he sent me a few minutes ago the presentation, so maybe he got lost in some of the rooms. Well, okay, I think we can start with the. It's quite strange because at least the fourth. Okay, maybe we will start the presentation with at this point from the third paper, and so you are Priscilla Benedetti?
Yes, I am.
And Priscilla Benedetti will present the contribution entitled Skin Cancer Classification Using Inception Network and Transfer Learning. You can start by sharing your screen, Priscilla, and giving your presentation.
Okay, can you see my screen now?
Yes.
Good. Okay, so good morning, everyone. I am Priscilla Benedetti from University of Perugia, and today I present you our work, Skin Cancer Classification Using Inception Network and Transfer Learning. The automated diagnosis of skin lesions from dermatoscopic images using neural networks is a difficult task due to the scarcity of samples and variability in available datasets. In this work, we exploit transfer learning and the power of the inception network with residual blocks to solve a strongly unbalanced multi-class problem while keeping a limited computational effort. We trained our network on the Human Engaged Machine 10,000, a set of labeled dermatoscopic images representing 7 different types of skin lesions, either benign or malignant. These 10,015 images have been collected over 20 years from Department of Dermatology of the Medical University of Vienna and the skin cancer practice of Cleats Rosendal in Queensland. Here in this image, we can see some samples for each category: actinic keratosis, basal cell carcinoma, benign keratosis-like lesions, dermatofibroma, melanocytic nevi, melanoma, and vascular lesions.
Excuse me. Can you hear me?
Yes.
But I don't know. I cannot see the slide. I don't know if it's just my problem. Natalia, can you see also the second slide?
No, only the first.
So you are just seeing the first slide?
We only
only
looking
the
at the title.
Okay, wait.
Go to full screen.
Now you see also the first slide.
Yes.
It is changed.
The second, yes.
Yes.
Okay. Maybe it's a problem of the full screen presentation, I guess.
Maybe.
Okay, so where was I? This is the image of the samples. Can you see it?
Yes, the dataset.
Okay. So we have these 7 kind of skin lesions, where the ground truth for each image has been confirmed with different methods, such as histopathology, follow-up examination, confocal microscopy, or expert consensus. If we look at the frequency of each label in the set, the great imbalance between melanocytic nevi, a benign lesion, and the other classes is manifest. Moreover, some kind of lesions like keratosis and melanoma present samples with similar feature. The available images present a great variation in the objective lesion size. For this reason, we chose to use a network weighted by inception modules. These modules, as we can see from the figure, if you can see maybe in the example block of the STEM module, use filters of different size, operating at the same level with multiple chip convolutional operations. Moreover, in the specific inception network of interest, Inception ResNet version 2, the introduction of residual connection, which replace pooling operations within the main inception modules and skip some layers, entails a lighter training effort for deep networks and reduces the impact of vanishing gradients. This structure, in which in this image I show you the overall schema, has been extended with a final module consisting of a flattening step, 2 fully connected layers of 64 units each, and a softmax classifier. The overall module is trainable on a single GPU with reduced memory consumption. Since the original dataset,
can you increase the size of the slides, because it's not in full screen mode and it's difficult to read everything.
Yes, but it seems that if I enable the full screen presentation, they can see just my first slide. Maybe I can try again,
Try to click
if you like.
presentation in the toolbar, and the buttons will hide. Okay.
Okay, let's try like this.
And the top bar.
Okay.
Thank you.
So it's better? Okay, thank you. Well, I was saying, so since the original dataset was strongly unbalanced, we choose to rebalance it by pruning images from the most populated category. After this shrinkage, we obtained a maximum of 450 images for label. This significant decrease of available samples is then mitigated by applying a step of data augmentation with the OpenCV library. In order to get more training samples, we augmented the training set by altering images with small transformation to reproduce some variation, such as horizontal flips, vertical flips, translations, rotations, and shearing transformations. We also use class weights to put emphasis on the recognition of labels with fewer samples, such as actinic keratosis and dermatofibroma. The training process consisted of 2 steps. A first baseline training phase with the following shorter one. After the
Currently, excuse me, Sheila, currently I'm still I
first
still see
slide.
the training process slide. I don't know if this is correct or
Yes,
not.
yes. I'm still on this slide. Okay. Maybe I'll notice you when I change it, so you can check me out if you can see the new slide, okay? So I was saying that the training process consisted of 2 steps. A first baseline training phase with the following shorter one after the rollback of the previously obtained best model. Now I change the slide. You can see the slide changed?
Yes.
Okay.
Yes.
Okay. In this work, we use the Keras framework with TensorFlow to tune the last 40 layers of the Inception ResNet version 2, previously trained on the ImageNet dataset. When the number of parameters exceed the number of data points, widely used adaptive optimizers such as ADAM or ADAGRAD could offer a worse generalization capability compared with non-adaptive methods. So we opted for a stochastic gradient descent optimizer with momentum and Nesterov accelerated gradient in order to adapt updates to the slope of categorical cosentropy loss function and speed up the training process. The first training phase has been made on small batches of 10 samples each for a maximum of 100 epochs, with early stopping to mitigate overfitting. Here is shown the confusion matrix. Can you see it? Sorry, can you see the confusion matrix?
Yes.
Okay.
Yes.
For the best baseline model, obtained in 30 epochs with a 73.4% accuracy. 2 of the minority classes, actinic keratosis and dermatofibroma, as you can see, are not properly recognized. It is interesting to note how melanoma is often mistaken for a generic keratosis. And this is interesting because it is a common mistake also in dermatologic unaided eye analysis. So, after the second training process of 20 epochs to explore other potential points of local minimum, this is the final confusion matrix. Here, it can be seen how the final model is able to recognize with good accuracy 6 out of 7 classes, even in presence of extremely limited sample sets, such as vascular lesion with just 30 samples and dermatofibroma with 16 samples. For this best model, we reached an accuracy of 78.9%. The whole process has been executed in a Google Colab virtual environment, and it has required a total training time of 4 hours, with maximum RAM usage below 20 gigabytes. Seeing the small amount of available images, these results are encouraging as a starting point for further projects, such as the implementation of a lightweight diagnostic support system for dermatologists, or an application for a self-preliminary risk analysis. But in order to improve the accuracy and robustness of this network, we need more images with reliable labels. I hope you've been able to see all my slides, and thank you for your attention now.
Thank you.
Thank you very much for your very nice presentation, Priscilla. Is there any question about this presentation? No questions? Well, actually, I have a number of questions, but I will just ask a couple of things. Essentially, you are doing fine tuning, which is more difficult than the typical transfer learning. But I'm wondering if you have enough cases, because for fine tuning is highly at risk of overfitting. So more common approach is to use just transfer learning, in which you only use the first layers of the net for extracting, for recognizing, extracting features, no? So did you check did you quantify, did you quantify the overfitting phenomenon in your application? This is my curiosity, essentially.
Okay, yes, we made attention to the overfitting phenomenon, and it is for this reason that we put some early stopping on the total number of epochs for the training, because as I said before, we initially set a maximum number of 100 epochs, but we've seen that after the 25 or 30 epochs, it started the phenomenon of overfitting during the training process. So we stopped this step to reach which was the best model without overfitting on the validation set.
Okay, thank you. But the partition of the data set among test set, validation set, sorry, maybe you show it. I couldn't see how many samples did you use to test after the training?
Yes, because of this great imbalance in the data set, as I told, we did a great shrinkage of the data set. So starting from a set of 10,000 images, we find ourselves with just an half of the images available that we later augmented for the training set, without augmenting the validation set that we use to validate the data. But after all, we still need another set, indeed, of reliable labels, of reliable images with the ground truth, the overall model, and for the robustness, in fact.
Yes, it is actually a difficult problem because of the imbalance of the data set. Okay, thank you very much for your nice presentation.
Thank you
now,
too.
I would like to check if maybe one of the presenters of the first paper is maybe here. Is there anyone in the meantime for a comparative analysis of demand forecasting method? No. And is there any presenter for the second paper? Classification of carcass fatness? Apparently not. But maybe I hopefully for the. Is there any presenter for the last paper?
Yes,
Vladimir.
Yes.
Yes.
Do you listen to me?
I cannot hear. I cannot see you.
Yeah, I got problem with video, but I guess the audio is okay.
Okay, but you can share your screen.
Yes, sure.
Okay. Vladimir Shaknov will present a contribution entitled "A Criterion for IDS Deployment on IoT Edge Nodes."
Okay. Did you see this one?
Yes, we can see the slides.
Okay. First, let me say thanks to you. Now we have the time and wish you health for all of you. Actually, I'm working in Ulsan University. But originally, I come to Korea from Russia, Novosibirsk Scientific Center, in February, and I have to finish my sojourn in the end of May, but no air connection, so I extend my contract here, and now I'm a research professor of University of Ulsan. I have two others from University of Ulsan and from Novosibirsk Scientific Center, Institute of Computational Mathematics and Mathematical Geophysics. And in our intrusion detection system is in the focus of our consideration, and we consider some kind of strategies for IDS deployments, and mostly applied for area of IoT edge computing. This is a part of some of our international projects, and mostly we focus on IoT security in this project. So IoT comes, and there is some great benefits, and a lot of countries, these are hot topics for a lot of countries, and actually ICCSA estimate about 50 billion connected devices by this year, and also I found some estimation of also provided by ICCSA that data produced by IoT devices will exceed 500 zetabits in this year as well. So this is a great benefit, and also this is a great challenge, because actually the world community is seriously concerned about the social cost of IoT-related benefits. And actually, security experts have warned of potential risk of huge number of insecure devices. There are some kind of estimation that only 10% of enterprises feel confident that they can secure those devices against intrusions. So it looks some kind of background for and some reasons for concern of world security, and you can see this is some kind of slice of media. Of course, it was about 1 year before current situation, before COVID. But it looks, at least a couple of years ago, it was some kind of different reason for the panic in, in world media. So you can see popular media rarely warn that IoT can be really danger. And actually, really, if previously we consider some DDoS attack or some other security attacks, and the issues of the attacks was maybe some confidential information disclosing or temporal availability of communication service disruption. But currently, issues of this attacks, IoT is a ubiquitous system, and actually use it in all important thing of our life, it looks like. So currently issues of these intrusions, I mean IoT threats, disable home security system, root fields, disrupt hospital, and so on. So actually issues are really serious of intrusions. And this stops development and implementation of IoT applications. So to unlock IoT potential, it needs to improve security for our IoT applications. And there are a few strategies for this one. Actually, if we say in general about CI triad, so confidential, all level of CI triad involved in this area, and also if we consider some security system, generally it gets 3 levels of prevention, mitigations, and detections. And as we consider some novel thing, really, maybe last couple of years, I saw at least 10 principally new intrusions. So it seems no good way to use to focus only on prevention systems. So intrusion detections become some core levels in the modern security system for applications. And also we need to keep in mind that generally, if we consider some IoT devices, we have to think about poor resources, low memory, and low battery consumption, and so on. So also this is some conclusion of world community, IoT community, that conventional security mechanisms cannot apply it effectively. So we try to think about some strategies of IoT deployments and provide some technique for quantitative analysis of this one. At least we try to do this one. So let's see. Also, some novel trend that IDS. Previously, we generally consider intrusion detection system implemented and detect some attacks by distribution detection. So it was distributed system, collect information from great areas and provide some kind of some conclusion, general conclusion for this one. Currently, there are some way and there are some demand for in-device intrusion detection because some kind of new novel attacks, like for example, depletion of battery attack, can be implemented as follows. In general, QoS can be improved. So if we use general detection of these attacks, we get conclusions that nothing happens, and moreover, situation can be improved. But particular some kind of specific device can be under attack and faster be distracted. So you can see there are some demand in not only in academia, also from industry to get some kind of systems for in-device intrusion detection and develop some approach for this. And at the same time, you can see edge device categories. This is also comes from IEEE learning networks, education learning networks, and this is some taxonomy of edge devices. And you can see most of devices get some restricted resources in terms of RAM, so computational facilities and battery and so on. So this is some challenge we have to keep in mind, and when we think about strategy of IDS deployment. And we consider just two current situations. So we just get some kind of traffic for edge nodes and treated by edge gateway and so on. Some set of edge nodes work and treat some traffics. And in first case, we do not use any IDS. In second case, we apply some IDS, deploy some IDS on in-device manner. And in this case, in the first case, we get some kind of losses because of some limited resources for edge devices. We consider only if we focus on real-time applications, then probably we have to reduce number of requests in buffer. So this is the reason we initially focus on no wait and room queuing system application in this case. And let's see. In the first case, we get only some drop some packets. So this is a probability B, blocking probability. B is the blocking probability, and we make some in our model. We make some assumption about Poisson distribution of incoming flow and also request treated with exponential service time. This is some standard assumptions for this type of system, and we take this from the literature. So in second case, we also get we reduce some number of spoofed requests, so it can be packets, for example, in flooding attack. But actually, we increase the time of packet treatment compared to the original case. So we need to, we use IDS, but we need to pay something, at least in terms of computational time. And this is the one thing. And also, we need to pay in terms of some mistake. So if we use some algorithm for detection of something, for recognition of something, we get two types of mistakes, false negative and false positive. So at least part of legal users packets can be dropped by non-perfect intrusion detection algorithm. So in this case, we calculate losses in both cases, and we just provide comparison of this loss rate in first case and second case. So if second case less, then probably we need to think about intrusion system, and at least we can formulate requirements for IDS in this case. And if we, this is our assumption, so we assume that some collection of edge nodes works as a relevant cost model with the scaling system, and blocking probability is described by relevant before well-known famous relevant B formula. As we consider some kind of limited resources, so compared to a number of devices, we have some relatively low, higher offload intensity. Then in this case, we get some useful theorem. So B is a R1B function. So you can see if the ratio n and rho is reasonable, so rho compared to n is large enough, then we can use simple. Actually, this is a low bound, but we can use this low bound in terms of approximation as approximation. So it's a simple expression, so we can easily get inverse function as well for this one. And this open for us some facilities for analytical technique, and we can get some closed form solutions for some set of problems which previously solved only by simulation, for example. For example, proportional differentiation service providing. Using this simple equation, we just develop some previous slide formulas and get criterion in terms of computational overhead. So if our IDS increase some kind of computational intensity number of times, then we can calculate is it reasonable to use this IDS or not. And also we account.
Sorry, Vladimir, you run out of time actually.
Okay, this is this is all that holds. Okay, so just finalize. We provide some criteria, and we keep some quantitative conditions for overheads in terms of computational times and in terms of quality of intrusion detection algorithms. Okay, thank you. Okay, any questions?
Okay, thank you, Vladimir, for your presentation. Is there any question? Apparently not. Okay, Vladimir. Well, actually, I am interested in understanding about the overhead. Maybe it is the previous slide, no? Okay, because so the overhead is relatively. In practice, my question is: in practice, is this overhead reasonable for common users? I mean, do the users will be affected by this IDS overhead? Because in practical terms.
Yeah, understood. So you need to see number of spoofed packets and ratio of users. In the left picture, for example, you can see if number of spoofed packet only 10%, then no any reason to use IDS in this case and to spend for something for overhead. So even if you use ideal intrusion detection system, so we get just if you just only spend 10% of overhead, so not high. So maybe actually SVM based classifier provide maybe about 20-30% in our experiment overhead. So at least if number of legal packets maybe 90%, only 10% of spoofed packets, then no reason to use IDS. So our conclusion, for example, in this case. If less maybe than 40%, then yes, it depends on quality of intrusion detection algorithm. So this is some kind of important thing.
Okay, very interesting. Thank you very much. Okay, I think this was the last paper of this session, so I would like to thank the presenters and also all the people attending this session. And
I
Thank
see
you very
Igor
much.
Nucci in chat, the second speaker.
There is another.
Igor Nucci, second speaker.
Really?
Actually,
Great.
it seems we start early, one hour early, right?
Please.
Yes, I am here. Can you hear me?
Okay. We had we skipped you because we couldn't see you previously. So this is why we skipped your presentation.
Some problem with my microphone.
Progress. Okay, fantastic. No, we are very happy. We are very happy to see you. And so you are the second. You are presenting the second paper entitled "Classification of Carcass Fatness Degree in Finishing Cattle Using Machine Learning." So you can share your screen and start your presentation.
All right. Can you see it?
Yes.
Yes, we can see the
In full screen too?
we can see now the title of the presentation.
Okay. And the next slide is okay?
No?
Yes, now...
I cannot see the next slide.
All right. So
Now
it's only the
now
first
it's okay.
slide. That's okay?
No, now it's also the second slide.
Okay. So we have some delay, I guess.
Yeah, there is some delay, yes.
All right. My name is Igor. Hi everyone. In Brazil, I am in Brazil. In Brazil, it's 3 a.m. So forgive me. Sorry if I am a little slow. I'll be talking about classification, classifying the degree of carcass fatness in beef cattle, and how it can help precision farming in the region. So Brazil is the largest exporter of bovine meat in the world, but we have difficult to export for markets that pay most because of the quality of the beef. To try to achieve more beef with more quality, the government created bonus programs for slaughtering younger animals and carcasses with high quality fat indices. So this program pay back the tax that the producers have to pay to the government. So if the producers produce beef with high quality, they do not need to pay the tax. So to see here how they need to get the carcass. They need to stay to get the bones in the 2, 3, and 4 carcass fatness degree. So it's low fat, medium fat, and uniform fat. And the government doesn't pay the tax back if it is in missing fat or excessive fat. And the animal must be less than 4 definitive teeths. So it needs to be very young, about 1 year of life, 3 years max. So our proposal was to collect the data from the state program called Precoce MS, which is a state program of my state, Mato Grosso do Sul, and use it to create a machine learning model. So the producers can produce better meat based on how to create their cattle. So we pre-process the data from the Precoce program by combining the data sets from the farm production process and the data from animal slaughter. And the final data set has just over 1 million data and a very unbalanced data set. You can see that carcass with no fat and excessive fat, there is practically none of them. So have to work with a high unbalanced data set. Just going to material and methods, the complete method can be seen in this figure. We started with the data collection of the program Precoce MES, which we have to send a lot of documents to the government to get this data. Then pre-processing it. So it was very categorical columns. So we have to turn them numeric. Balancing the data. So we use three types of balancing the data that I show. And making model selection using cross-validation, grid search, and 6 algorithms. So how it was made? We tested 6 algorithms: multinomial naive, random forest classify, ADA boost, multilayer perceptron, KNN, and support vector machines, and used 3 balancing models. Undersampling, detect nearest neighbors, oversampling with SMOT, with synthetic, we made synthetic samples, and a combined called SMOTing. So we made undersampling and we removed the data using undersampling. So it's a combined. We have the best results using undersampling and with the random forest classifier, which we get 70%. So in the confusion matrix, we can observe that there's a lot of confusion in the classes 1 and 2, which is very bad because class 1 doesn't pay back the tax. So if the producer produces a carcass with no fat, they are considered a very bad quality meat. And the 5 with excessive fat, so it not paid 2, just pay for 2 for classes 2, 3, and 4. And if you are confusing between class 2, 3, and 4, there is no problem because the government will pay the tax back too. So it only cannot get class 1 and class 5. So we made the Hock curve to show that our result was very good with the random forest classifier, which are very stable. And to conclude, it was a satisfactory result because before that we had nothing. The producers just used their intuition to produce, how they have to feed, how they have to, if you make the cattle confined or not confined. So they were based in
It is changed.
what? So it was a very satisfactory result because the producers now they have 70% of chance to know if their productive process are good or not good, or if it will produce a better carcass. So thank you very much. If you have any questions.
Thank you very much for your presentation. Is there any question?
May I ask?
So we have a question.
Would you please show slide 7?
Okay.
In support vector machine, what kind of kernel function do you use? Linear, polynomial, or radial basis?
I use it now. I use it grid search to select the best kernel. So the RBF was the selected in this case.
Just my opinion. Actually, we experiment with almost this one techniques in my problem in present detection,
Okay.
and it looks some quality of detection also depends on the kernel function. So maybe I guess in your case maybe linear will be provide some kind of better result, but just opinion. I don't know. Just opinion. Okay, thank you.
Okay. I think I didn't understand the question.
Vladimir, maybe no. Sorry.
Yeah.
Maybe you should talk more closer to the microphone. Try to talk closer to the microphone.
Yeah, just I just provide my opinion. I guess maybe it's reasonable to experiment with some different type of kernel function, not only RBS, also use linear or polynomial function in this case. At least in my research in idea system, projection system, it quality is generally defined. Also depend on the radio function. I cannot. I have a theoretical explanation of this one. It's just some experimental result. It looks choice of kernel functions work like threshold value in cumulative sum algorithms. So we can get trade-off between false positive and false negative if we properly choose kernel function. I just provide some idea, maybe try to present, maybe try to use some different type of kernel function.
Yes, I will try that. Definitely. We use it grid search to search for the best parents, but we don't have very best machines, so sometimes the SVM take a lot of time, and we can't collect all the data of all the kernels we tried.
Yeah, okay, thank you.
Okay, thank you very much also for the discussion. Thank you, Igor. Thank you, Vladimir. Thank you to everyone who attended and presented this session. And so that was the last paper. And I will see you in the next sessions of the conference. Goodbye.
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 Arrivederci, Natale.
Arrivederci. Professore, come sempre le ricordo di compilare il paper.
Certo.
Grazie.
Sì.
Grazie. Arrivederci.
Arrivederci.
is on.
Hi everyone. Could you please insert your name?
Hi everyone, my name is Julio.
You have to insert your name in the bottom of the screen. There are more action.
Yes.
And it is the first item of the list. Thank you. Hi everyone. I don't know if there are all the presenters. Mohamed Shbai. Management of context in mobile environments. And the second speaker, an evaluation of low quality content detection strategies.
Yes,
Who is the speaker?
I,
The name and surname, please.
Julio.
Julio.
Yes.
The surname?
Julio Rezende.
Okay. Paolo, I can see Paolo Zola.
Yes, I'm here.
Paola, I'm sorry. And the last one, Mustafa. Okay, perfect. We are three. We will wait, or I'll go on. What do you think, Natale?
What?
I can start.
Yes, yes.
There isn't a presenter, but if he will come with us, he will speak later. Welcome, everybody. Welcome in the General Track 5, Information System and Technologies. We will start with the first speaker, Giulio, that will present an evaluation of low-quality context detection strategies. So, go on, Giulio.
Okay.
Can you show us your face, please? Oh. Okay, perfect.
Hi, my name is Júlio. I'm a master's student in computer science at Federal University of São Paulo, Brazil. And the title of research I will be presenting is an evaluation of low-quality content detection strategies, which attributes were still relevant, which are not. Okay then, let's get started. As you might know, social networks are part of our daily lives. Among other things, they have a lot of information on a wide range of topics. For instance, entertainment posts, political, social, and personal information, and many other advances. But is having this massive amount of information at our disposal a good thing? It turns out that the answer is no. Social networks have a lot of low-quality content. Low-quality content is nothing but spam in the broad sense, which includes automatically generated content, false information, frauds, clickbaits, malicious links, among other harmful content used. An example of a widely used social network, there is Twitter. I'm sure most of you have heard about it, right? Tweets receive more than 700 million publications daily. In Twitter, there is not a limit for the frequency of users' publication. Twitter has a spam filter is only based on a blacklist of URLs, and it can't deal with shortened links. It is an ideal environment for the propagation of low-quality content. Because of this bunch of information available online, identifying low-quality content has been widely explored. Traditional approaches propose some classifiers to explore basic research, such as blacklists of URL and user IDs, or even so improved research, such as the distance between sender and receiver. Considering the traditional approach, there is not a consensus about what is spam. Most research focus only on the detection of spammers or malicious links. Additionally, most techniques are not applicable in real time, and several research are no longer available. So we decided to look in which attributes were still relevant, which are not. Our goal is to analyze existing methodologies in order to identify which attributes were most relevant for the detection of low-quality content in real time. We hypothesize these public and weightless attributes may guide the classifiers to improve its detection of low-quality content. In our literature survey, we identified methodologies with different restrictions to our proposal, divided in 4 main groups. Account detection. It doesn't detect the malicious content, but only its owner. This works ignores the possibility that common users also publish low-quality content. Malware pitch only explores URL blacklists. Private research. It usually explores resources that are no longer available in the public Twitter APIs. And graph-based work. It traces the communicative path taken by users by exploring a lot of information that are often computationally expensive, which makes detection real-time hard. After reading several papers, we decided to conduct an evaluation. We surveyed all the available features used in the related research and then set out to carry out an analysis involving classifiers. The dataset was proposed by Shen et al. 2017 and classified according to the user's perspective about what is low-quality content. Respecting Twitter's privacy policy, the authors only made available the tweet IDs and Twitter class, low-quality content or normal content. We collected the corresponding tweets and their attributes through the IDs available. We got a little more than 40,000 tweets, in which almost 4,000 were classified as low-quality content. The table shows the evaluated attributes. Attributes 1 to 15 refer to user information, such as the number of followers and the average number of tweets per week. The attributes 16 to 35 refer to the tweeter's information, such as the number of words in the tweet. About the attributes analysis, first we apply the InfoGain and the chi-squared feature select algorithm to score each attribute. Afterwards, we create n sets with the highest scored attributes, increasing the number of attributes gradually. We evaluated each set using the random forest classifier, which produced the best results in previous work. The performance metric was the F-muser of the lowest sampling class, and the sampling was cross-validation tenfold. The graphic shows the result of both feature select algorithms. Here you can see that the tool used to post the tweet, attribute 16, has higher relevance, while the symbols in the tweet, attributes 27, 28, and 35, has little relevance. In this graphic, we can see the F-muser of the sets with the n best features using the random forest classifier. Exploring almost all attributes, 13, the result the method achieves the higher accuracy. However, only exploring the 14 best attributes is enough to ensure a F-muser above 70%. In the second step, we did a more complete analysis. We compared 4 sets of attributes. The first set with the 33 most relevant attributes. The second with all attributes, the third with user attributes only, and the fourth with tweet attributes only. In addition to the random forest classifiers, we also used the SVM classifier. The models were evaluated using cross-validation tenfold and compared using the following performance metrics: accuracy, true positive rate, F-muser, and macro F-muser. The table shows the results of our analysis. Random forest classifiers has the best performance in all case analysis. All datasets generate models with accuracy above 90%, but it's not the best way to analyze our results because our dataset is unbalanced. Analyzing the true positive rate and the F-muser, we can see that the model trained with only user attributes didn't perform well. On the other hand, only using attributes of the tweet ensures a result as good as the one achieved by using all attributes of the 33 most relevant attributes. So, to sum up, this work, we did a literature review focusing on the detection of low-quality content on Twitter. We list all attributes still available that can be used for real-time detection, and the different combinations of attributes were evaluated with the random forest and the SVM classifier. We conclude that using only attributes of the tweet can generate a satisfactory result. This is an important finding of our work because the use of user information has been increasingly discouraged. Well, that brings me to the end of the presentation. Thanks for your attention.
Thank you, Giulio, for your presentation and also for respecting the time. I think that maybe it could be better to move the discussion at the end of the presentation. In this way, we can collect all questions and we have the time to better listen all the presentation. Are you agree?
Okay.
Okay. So, and also the other presenter are agree?
For me, it's okay.
Okay, perfect. Okay. So we can go on to the next speaker, Paola Zola, that she will present using Google Trends Gaussian mixed model and dbScan for the estimation of the Twitter user home location. So Paola, please.
Yes, I'm doing. So, can you see the presentation?
Yes.
Okay. So, I'm Paola Zola from the National Council of Research in Italy. Oops. And I will present this paper in which we apply Google Trends clustering model for the estimation of Twitter user home location. So the problem to locate, it's movable file itself. The problem is to locate Twitter user home location. It's a well-known problem in social media analytics. Our proposed solution aims to find the coordinate of Twitter user home location and on the entire globe surface. The main novelties of the proposed approach is the usage, the application of Google Trends under its spatial perspective. So Google Trends is a well-known engine provided by Google, which furnishes statistics about searched queries around the world. The statistics provided by Google are both under a temporal and spatial point of view. However, scholars mainly used the temporal perspective of Google Trends, for example, for predict flu trends, time series forecast, and so on. Using the spatial information of Google Trends is still a new task that we apply in our preceding work, but at country level. So this work is more challenging and more intense. Here, this slide describes the proposed approach, which is composed by 5 steps. So we start from a user and we collect her past tweet, so her timelines according to the Twitter API service. From the timeline, we extract all the nouns, so proper and common, and also location indicative words if present. And all these nouns are passed to Google Trends, and Google Trends provide the city distribution, so a list of cities, and to each city we got a value.
Paola,
value,
just a moment. I see just the first page of the presentation.
You are speaking with only the first one. Okay, perfect.
Can you see like this?
Yeah, the first.
Yes, go.
It's better to use because before was a large screen and maybe you don't see. Now if I move, you see?
Yes, go.
Okay, I think the first 2 slides were very easy, so we can continue from the proposed approach.
Okay.
Okay. We got user timeline, we extract nouns, and the nouns are passed to Google Trends. Google Trends give a list of cities, and to each city is assigned a score. We are here in the proposed approach. This score is not the full number of searched terms in the city, but it is a normalized value in the range between 0 and 100. Then we need to cumulate all this information to create a sort of synthetic word level dataset, and we apply the clustering algorithm to define the final user location point in terms of coordinates, so latitude and longitude. The estimated location are then evaluated with a baseline, so the user real home location. The dataset that we used is composed by 3,000 Twitter accounts with a verified location, and it is fully available on GitHub because it's the same dataset of our preceding work. In order to better explain the proposed approach, I will follow an example, a practical example of how it works. So let's start from these 4 tweets, which are the tweets of a user. And for each tweet, we extract the nouns. So for example, here we got Knicks, afternoon, cheesecake, and so on. Each of these nouns are then passed to Google Trends. And Google Trends provide the city distribution, which is a list of cities and the correspondent value. Here I just put the first 8 cities, but the list is longer. And we got, let's suppose that the user has only these 2 nouns. We need to summarize the information for each noun to a cumulative distribution, which is here on the right-hand side. So, for example, we got that New York is the most frequent countries according to the Google Trends queries about Knicks and de Blasio nouns with 190 score. So a simple method would be to assign to the user New York as its city. However, it's a simpler version because we are removing all the following information about Yonkers and Philadelphia. And in particular, Yonkers is a city very close to New York. So to take into account the possibility that the user is not from the center of New York, but from one area which is between New York and Yonkers, we create a system based on city polygons area. So for each city, we create the polygon of its area, collecting the borders from OpenStreetMap. However, as the top figure shows, the OpenStreetMap raw data have some limitation. So we have strange lines in the border. So to solve this problem, we adopt the algorithm proposed by Moreira, which is based on key nearest neighbor, and we got the bottom figure with the correct polygon shape. Now that we have the polygons, within the polygons, we have to replicate the cumulative Google Trends distribution. So for the specific case, the example, we have to sample n 119 random points. So this is how the Google Trends distribution comes to the synthetic dataset. Enlarging the analysis to the entire world, we got that the user is now described as a collection of points on the world surface. And to define which is the final user home location, now we need to apply some clustering algorithm in order to understand which is the most probable cluster and which is within the cluster the most probable user location. We adopt two clustering algorithms, which are the Gaussian mixture model, which is a probabilistic clustering models based on k linear combination of Gaussian distribution. And we have just one parameter k that we range between 1 and 50. And the DBSCAN clustering algorithm, which is a density-based algorithm. And in this case, we use the default parameter provided by scalar Python model. We evaluate the performance, computing the mean absolute error and the median absolute error over the aversing distance expressed in kilometers. Moreover, we also compare the result with a baseline, which is the simply city mode. So New York, for the example, for the proposed example. Here we got the result of experiment. So we have a mean absolute error and the median absolute error for the Gaussian mixture model in DBSCAN. In terms of mean average error, the best model is the Gaussian mixture model, while considering the median average error is the DBSCAN.
Paola, I'm sorry if I interrupt you, but I have the unpleasant to tell you that you have 2 minutes.
Two?
Two, yeah.
Yeah, yes, it's enough. Thank you. So both methods, so Gaussian mixture model and DBSCAN, are better than the baseline. And even if it seems a big error, because 1,700 kilometers for the DBSCAN median average error is not a small distance, but we are considering all the globe surface. So we are enough confident in this result, in this algorithm. Here we report an example of how the two algorithms work, so the two clustering models. We got the Gaussian mixture model with at most 10 clusters and the DBSCAN, which has a huge number of clusters. But in this case, DBSCAN predict the user home location in South Australia, Italy, which is correct. However, the Gaussian mixture model wrongly locate the user in United States. It's a huge error because the distance between United States and South Australia is huge in terms of kilometers, and this push up the errors of the models. Unfortunately, this kind of error is a common error for this approach, which has difficulties in locating Anglophone nouns. So in future work, what we aim to do is to improve the performance of this initial approach, trying to solve the problem of Anglophone countries and also applying other clustering algorithms, for example, k-means and others. So I complete the presentation.
Thank you so much, Paola. I have some questions. Maybe if we have time, I will ask you later.
Okay.
The next speaker is Mustafa Al-Gamdi. It's correct?
Yeah, it is. Can you hear me?
Okay. And the presentation is quite an ensemble methods for predicting train delays. So,
Hello,
Mustafa.
can you hear me?
We have some difficulties to listen. Could you please try again to speak?
Hello. Hi, everybody. Yeah, I'm just like trying to speak. Can you hear me right now?
I don't know if only my problem. You are able to listen, Mustafa?
Hello, everyone.
Okay, yeah, you listen.
Okay. So go on, go on.
So can you hear me right now?
Yes.
Yes.
Okay, perfect. Yeah. Okay, perfect. My name is Mustafa Al-Gamdi. I am postgraduate in computing school at the University of East Anglia, UK. Today I'm going to present a paper titled Weighted Ensemble Methods for Predicting Train Delay. Here is the outline. We're going through introduction, problem, methodology, experiment, result, and the final conclusion. Uh, Train delays have become a serious and common problem in the real service due to increasing number of passenger and limited real network capacity. So, being able to predict train delays accurately is essential for train controllers to prevent or to reduce train delay. And this paper presents a machine learning ensemble framework to improve the accuracy and consistency of train delays prediction. And the basic idea is to train many different machine learning algorithms. Uh, can you hear me?
Yes, yes.
Yeah, okay. To train many different machine learning algorithms for each stations. Using historical data and relevant weather data, and then with a certain with a certain criteria to choose some models to build an ensemble, and then it combines the output from the pool of models with an aggregation function to produce the final prediction. And there are many facts that can cause initial delays, which are signaling issue, bad weather, damaged equipment, breakdowns, construction works, and accident. Uh, for the prediction model scheme, what we are predicting, our target is the arrival delay. And the way we calculate the delay is the data coming from the company that has the actual arrival and planned arrival. And we got the difference between the actual and the planned. And we are predicting between each stop station, like from the point A to point C, like S1 and S2. And this predict time will be taken together with the other variables as the input for next model for predicting the arrival time. Uh, the feature used to make this prediction includes the running time, weather conditions, whether is it on peak or off peak, during holiday periods. With these features, different models are trained as a candidate models for uh, predicting predicting train delays and for building a heterogeneous ensemble. Here is the our framework. As I said, like before, that we have two different data sets, like the data train and weather data, and the other components are basically for the life cycle of any machine learning. Our focusing on combination, and we have like two like methods for combining the model, two aggregation function where device to combine the models, the output of the individual models. The first one, the average ensemble, which is basically is just like decision making function simply calculates the mean of the output from all the number of models. The second one is weighted ensemble. In weighted ensemble, we employ another decision making function, the weighted average methods. The motivation is based on the fact that some models performs better than the other. So logically, their decision should have more weights than the those models whose performs are lower. So we calculate the weights based on the each produce like each performance of each individual model. And the accuracy was measured by the percentage of correct prediction of the arrival time for a train, and also the correct prediction within 1 minute to the actual arrival. For the experiment, we have run the experiment 5 times with different data partition, and we use the journey from Norwich to London Liverpool Street, taking delays between each station stop. And the data collecting from the training running data in 7 months between 2017 and 2018 from the HSP, which is the Historic Surface Performance. Weather data was also collected from the weather station nearest to the railway. And here is the our result. As it can be seen, the blue one is for the single models, and the orange one for the average ensemble, and the gray one for the weighted average ensemble. In general, the single models had an overall mean accuracy level of only 41%, with a mean standard deviation of 11.24.
You have another 2 minutes.
Okay, I'll try to just speed up. And the overall the average ensemble improved on average by 15% with a correct prediction. Here is for the critical difference diagram. As can be seen, the methods are linked with 2 fixed bars. The first one includes the weighted average and average ensemble, and the other group is the random forest with the single models. They show that our weighted ensemble are statically and significantly better than the individual models, and better than the other ensemble methods, although not significant. Here is the conclusion and future work. We can just like sum up: the ensemble significantly improved not only the prediction accuracy, but also the consistency, and the weighted ensemble are clearly the best. For the future work, we want to use the more data with which we already have collected, and more features and more types of models, as well as improve the predictions accuracy as much as possible. Thank you for listening, and if you have any question, I'll be happy to answer.
Perfect.
Thank you, Mohammed. Could you listen to me now?
Yes, I can.
Okay, perfect. There is the first speaker, Mohammed Sbai, now. Management of context in mobile environments. No, maybe it's not all right. So we can start the discussion. Do you have any question? There are some questions in general. I can start. I have a question to Paola Zola, and yeah, in relation on your methods, it's just a curiosity. Do you have a specific criteria on choosing the city, or it depends on the data?
Yes, in this case, it depends on the data. The problem are mostly to understand which noun are more useful to locate cities. So next work will be to better extract nouns, more significant nouns. But with city are all cities from Google Trends.
Okay, thank you.
Thank you.
Do you have any more questions? So we can conclude this session now, and I really thanks everybody for having presented your paper in the track 5, Information System Technologies, and we will see in the next session. Bye.
Bye. Thank you.
Bye. Thank you.
on.
Please set your name.
Hi, everyone.
Hi.
Could you please insert your name and your surname on the bottom of the page? There are 3 points that correspond to settings, and it is the first item of the list.
It's me.
Thank you. I think it's better for all of you, all of us, in order to understand who is the speaker.
Okay. Can you read it? Can you watching my presentation?
Yes, you are the first.
Yeah, but just 1 second. Just 1 second, please. We have to start at 11. Just 1 phrase for present the session.
Okay.
Okay, I'm sorry, Giulia. 2 minutes and we will start. So the presenters are Giulia Potratz. I'm sorry for my bad pronunciation. The second one is Yuri Palazzo is the third one. Okay. The second one is a smart ecosystem for learning and inclusion and an architectural overview. There is the presenter, the speaker.
Yes, it's me.
Perfect. You are Valeria Farinazzo?
Yes.
Perfect. Okay. And the fourth one, there is the presenter. Approach for the search for software projects similar in structure and semantic based on the knowledge extracted from existing projects? Not yet. Okay. One minute and we will start.
Okay, Chiara.
Okay. Welcome to the 5 general track. I am Chiara Garau, the chair of your session, and I think it's better to start with the first presenter, Giulia Potratz, that will present us large dimension parameterization with convolution variational Don't take counter. So Giulia, go on.
Thank you.
Okay.
Hi, my name is Julia Potratz. I'm a master's student at the Pontifical University Catholic of Rio de Janeiro. And today I'm going to introduce a little bit about the work developed entitled Live Dimension Parametrization with Convolutional Variational Encoder, an application in the history match of generalized geological phases models. I will start by introducing a little about the problem in question. Suppose we have a reservoirs model. Through this model, you can determine the production history of this reservoirs. However, what we have in really the opposite problem. We have the production data for these reservoirs, and we need a model that is able to represent this history. This is a variant of a history matching problem. Basically, the history matching process can be represented by this image. Assume the example of a reservoirs model. The properties of the reservoirs are parameterized by some methods. After this procedure, the simulation gives us the production data of these reservoirs. Finally, the combination of this information is passed by an optimization methods that will adjust the models in such a way that they can represent the production data. One algorithm is widely used for history matching due to its robustness and efficiency is the ensemble multi-data simulations methods. Being a method based on the Kalman filter, it assumes some premises as the causality of the data. However, most of the variables involved in this problem do not have Gaussian distribution due to the nature of the data, in particular the spatial distribution of rock types. The need for parameterization methods has driving search in this area. The use of techniques based on the deep learning has been promising in this area. The literature has pointed out the convolutional variational autoencoder network architectures have shown efficient parameterization methods for integration with the ensembles multi-data simulation algorithm. However, the dimension of the problems are worrying factor for these models. This is because the number of trainable parameters increase exponentially when we increase the size of the reservoir models, making network training unfeasible. This is the architecture of the convolutional variational autoencoder traditional. The fact that this architecture has 4 layers fully connected in the central part causes the number of parameters to grow as the dimension of the model increases. Using this graph, you can check the influence of the model size on the number of trainable parameters of the network. The number of trainable parameters grows exponentially with the dimension of the size model increase. In this work, we proposed 2 alternative networks architectures to try to solve the problem of the large dimension of the reservoirs models. We have formulated 2 innovate deep learning architectures based on the traditional convolutional variational autoencoder network to work with large images. Both networks are inspired by the convolutional variational autoencoder, one incorporating the inception models in its structure, and the other incorporating the deepwise separable convolution in its structure. For the convolutional variational autoencoder architecture introducing the inception models represented by these images, we have replaced most of the convolutive and deconvolutive layers for the inception models. We maintain the first convolution of the encoder and the last the convolution of the decoder of the traditional convolutional variational autoencoder architecture. We propose to reduce the number of fully connected layers to 3 and reduce the size of these layers. For the convolutional variational autoencoder architecture introducing deepwise separable convolution, we are inspired by the mobile net architecture. All of the encoder's convolution layers have been replaced with deepwise separable convolution layers. In addition, we have maintained the original convolutional variational autoencoder decoder network. After defining and training these architectures of both networks, we use the networks to find the history matching incorporating the ensembles multi-data simulation algorithm. The algorithm is representing this image. The encoder provides the prior parameters represented by this variable z. The decoder provides us with the corresponding model for each prior model. These models pass through the simulation and provide the production data. After these procedures, the production data along with the corresponding prior models pass through the ensembles multi-data simulation algorithm and update the initial models. This process occurs through propose networks architectures, we select two cases of two-dimensional channelized syntactic reservoir models, denoted here after as case 1 and case 2, respectively. The first case is a 45 by 45 syntactic models. The second case is syntactic models of dimensions 100 by 100. An example of each case can be observed these images. In case 1 has 30,000 samples divided into train and validation in the proportion of 70% respectively. The same proportions was defined the 40,000 samples for case 2. In order to tune the hyperparameters of the networks, we conducted several experiments. In particular, we focused on lot size and lateral vector dimensions, which was the most influenced the accuracy of the reconstruction. The best dimension for the lateral vector of the networks was 500 arrows, and the best back size for case is represented in this table. Through this graph, we can observe the influence of the dimension of the models considered in this work, and three more hypothetical cases on the quantity of trainable parameters of proposed works. We can notice that the number of parameters increased exponentially as the input dimension increased to the original convolutional variational autoencoder architecture, or baseline. For the networks incorporating deep-wide separable convolution, the increase is gradual. For the network incorporating the inception models, the number of parameters is not changed for any input dimension. These results indicate that new architecture is based on convolutional variational autoencoder and scalable to large reservoir models in terms of number of trainable parameters.
2 minutes for conclude.
Note that network's abilities to represent the realism of the models as well as the original convolutional variational autoencoder network. This table represents the accuracies of the reconstruction of the networks for both cases. This image represents the initial case 1 models and their reconstruction using the different network configurations proposed in this work. In this image, we are ready to see the initial models and reconstruction using the different network configurations for case 2. From this image, we can see that the parameterization methods using convolutional variational autoencoders network with the respectively changed integration in the ensemble multi-data simulations algorithm can find reservoir models that comply with the production history for both cases. The white circles represent the observed data, which is the production history. The black lines represent the final models found in process of history matching. This work showed us that the proposed parameterization methods integrations to ensemble multi-data simulation optimization algorithm proved to be efficient, especially when it comes to scalability for large-scale models, preserving the ability to maintain geological realisms as well as the original convolutional variational autoencoders network. This is. Thank you, everyone.
Thank you, Giulia, for your presentation, and thank you also for the time. So the next presenter, the next speaker is Valeria Farinazzo, and she will present a smart ecosystem for learning and inclusion, an architectural overview. I'm sorry, maybe it's better if we move the discussion at the end of the session. In this way, it's possible to listen all the presentation and later increment the discussion. Are you all agree?
Yes.
Okay, perfect.
Do you have my presentation, Karen?
No.
No.
Maybe it's better because it's better if you manage by yourself your presentation.
Okay.
For you, it's a problem? Do you have your presentation, or for you, it's better?
Yes. How can I share my screen here?
is the first
yes.
icon on the left, on the bottom of the Gypsy page.
Yes. Oh. Just a moment.
The presentation sharing was for put all people to check and to show what the presenter will present. So if you need more time, we can go to the next presenter, or we can wait.
Just a moment. Yes, please.
Yes, please. What you will speak, or I will go to another.
I can see. I can talk in the next presentation, please.
Okay, perfect. Okay.
Thank you.
You're welcome. Yuri Palazzo.
I'm here.
Okay, perfect. So the next presenter is Yuri Palazzo, and the title of his presentation is The Navigation of Multi-Itineraries for the Cultural Heritage Context. So go on, Yuri.
Yeah. One moment, please. Okay. Can you see me?
Okay, perfect.
Perfect. Oh, good morning. I'm Yuri Palazzo, and today I'm going to show you the Search Path Service, a navigator for multi-itineraries for the cultural heritage context. And this project is based on Policina, a research project funded by Regione Lombardia that involves 900 students, 12 schools, and 26 cultural heritage institutions. Policina is a social learning management system based on the flipped learning pedagogical paradigm, which allows the students to build cultural heritage itineraries under the supervision of a teacher. But what is the flipped learning? In traditional learning, the teacher passes his knowledge top-down to the students. In the flipped classroom, students at home study and do homework, and in classroom make tests and discussions with the teacher. The flipped learning is an extension of the flipped classroom, in which students collaborate to make learning contents by ECTs under the supervision of the teacher. In this project, the flipped learning approach is used to make cultural itineraries. An itinerary is a set of ordered heterogeneous points of interest, for example, museums, sculptures, landscapes, buildings, etc. And when a user wants to plan an itinerary, typically go on a platform, query the platform, and the platform retrieve a subset of the itineraries. But choosing itinerary is not a simple task, because the same theme might involve different points of interest. The relevance of a point of interest with the thematic might be not clear. The itineraries might have a large overlaps, and the user can have a poor knowledge of the point of interest beforehand. The main goal of this project is to provide a tool to facilitate the comparison of many itineraries. For this reason, we've made the search path service a vertical application that retrieve itineraries providing summary cards, geographic visualizations, and conceptual maps. The service have three phases: search, selection, and navigation. In the first phase, when the user go to the platform, he can see his position by a locator, and he can query the system by the name or the address of a point of interest, by one or more concept, and he can select the means of transport. The system retrieves the itineraries and show that as summary cards, which contains the title of the journey time of visit, the points of interest in the itinerary, and the related concept. If user click on the top right of the screen, he can switch from the geographic visualization to the topological visualization. In the topological visualization, the itineraries as shown as a metro map in which each itinerary is a line and each cultural object is a station. If a cultural object is in more itineraries, this is an interchange station, like this station in Naviglio. If the cultural objects are ordered chronologically, and if more objects are from the same year, there is a station with many badges with the indicators or with the indication of the number of the badges, like this, 2 badges. If a user clicks on 2 badges, will appear the list of badges. If a user click on one of these badges, will display the preview of the badge. And finally, if click on the show details, you can see more information about. Thanks to the topological view, the user can see the difference between itineraries, the detailed information of the itinerary, and the connection between itineraries. In conclusion, the search path service helps the user to compare different itineraries for an improvement decision-making process based on multiple views and augmented information of the points of interest. Future works will include usability test of the service, develop an hybrid recommender system for itineraries based on several features like user preferences and social knowledge, and also we want to apply this service for generic touristic purpose because now this service is used only for planning school trips. Thank you.
You're welcome, Yuri.
Okay.
I have too many questions, but as I said before, we will speak about that later.
Okay.
And the next speaker is Valeria Farinazzo. The title of her presentation is A Smart Ecosystem for Learning and Inclusion, an architectural overview. Okay, Valeria, go. Valeria, you have your microphone off, so we have to start again. Valeria?
Yes.
Okay, perfect. Now we can see your presentation and we also listen to you. Go.
Okay, thank you. My name is Valeria Farinazzo. I'm from Mackenzie University in Brazil. My motivation is, this is a project, research project, involved 10 countries in the world. And we are in a context where people who are out of the society, like people with disabilities, homeless, immigrants, and you can see in this presentation. And in Brazil, you have all the problems together. These people has many problems with access to school, to education. Then came the idea of building an ecosystem to teach these people. This ecosystem should centralize in technology, pedagogical aspects, and be free, be open. This word is part of this project. The name is CELI project. This project involves 10 countries. Finland is a leader. This project is funded by Eranet. In total, more than 1 million euros are financed. And the project started in January the last year and finished in December of this year. Here's you have a link of this project. Here you can see many universities that is part of this project, like Finland, Turkey, Poland, Brazil, Uruguay, etc. Latin America and Europe based. Here you can see the architecture overview of this project. It is divided in 4 views: philosophical foundations, infrastructure, concept view, and service bus. About philosophical foundations, you can have shared pedagogy about these 10 countries. And we use it universal design to propose accessibility, open education, education for life, and citizen for the disability people, and you use it learning analytics infrastructure. In the infrastructure view, you have blockchain to generate the certificates of the courses. Microsites, each course created by the teacher is a microsite. And analytics are used to understand how students interact with materials generated by the teacher. In the concept view, we have an open part, open communities who can participate of this project, can use all the ecosystems. Open tools like course management tools or digital storytelling tool, and open content. Each course prepared here in this ecosystem is open, it's free, under a Creative Commons. This part of Service Bus, you have authoring service, authoring tool, where the teacher prepare your material, including accessibility to didactic material. You have CMS or an LMS service, where the student can see the available material, available course. Collaboration service, you have, for example, digital storytelling here, or you can incorporate open tools. Here you can see a screen about authoring tool, for example. The first part, you can see the ambient, the environment where the teacher prepare your course. And the second, you can see when the teacher can configure the accessibility part. Here, you can see the CMS, where the student can see the valuable courses to start. And the conclusion is this ecosystems has been in testing since last year in 3 countries, Brazil, Dominican Republic, and Uruguay. In this moment, teachers from public or private schools, accessibility specialists are using this ecosystem, the authoring tool specifically, and for future work, you need collect user opinion about the ecosystems, especially people with disabilities. And here I can think about Eranet LEC that funded this project. Thank you.
Thank you, Valeria, for your really interesting presentation. I have also for you some questions, but I said before we will give you this question later. And
Okay.
I'll wait. I wanted to check if the next speaker is here. Gleb Gustav. Maybe my bad pronunciation. Maybe it's better if I read the title. Approach to the search for software project. No, it's not here. So we can start with the discussion. Do you have any question before mine? Please. Do you have any question? Okay, I can start with you, Valeria, because you are the last, but not the least.
Okay.
I found really interesting your project, also because involved so many countries with a different law, with a different situation, and also because it started in November 2011. I understood well. It's correct. It started in few months ago. It's correct?
So, yes.
In November 2011. So
Yes.
my question is, there is a country most active than other, or why the combination between this country and not the other one?
The question is about the countries that is part of this project.
In using the smart ecosystem.
Yes, Brazil start the tests in November. Use tests with specialists in accessibility, and in this moment the ecosystem is start to ready. And you have many problems in this period, but the specialists said that it's a good ecosystem because it's not common to have a ecosystem that include accessibility part, but the teachers don't have how include accessibility is the problem. This is the main problem. Then you have now you prepare a course about how the teacher, common teacher, can incorporate accessibility part in your material to put this this idea in the platform. The platform, the ecosystem cannot do this.
Okay. Thank you. Thank you so much for your reply. Valeria, Yuri, do you have any question for Valeria, or we can go to your presentation?
Yes, we can go to mine, please.
Okay. Thank you, Valeria. Thank you again.
Thank you, Valeria.
Thank you. Thank you.
So Yuri, just a question. Maybe I don't know if I understood well, but I understood that your multi itineraries are applied only for students users.
Yes, yes. Actually, it's applied only for student user.
And why not only for tourist users or for other kind of users? It's just a curiosity. My
Yeah.
curiosity. So it's because
Yeah.
I understood the potentiality of your
Mhm.
of your idea. So
Yeah, thank you. Because the Policina project was born as a social learning management system, as a learning educational platform. The itinerary view was born after.
okay, perfect.
Okay.
And another question is, did you develop it in an app?
We make an hybrid app based on React.js.
Okay, it's just a curiosity, my curiosity.
Yeah.
And so, Valeria, do you have a question to Yuri presentation?
No.
Okay, I really thank you for your contributes, and we can close the session.
Thank you.
Okay, bye.
Bye.
Thank you. Bye-bye.
Bye.
Okay, I guess we can start our session. Before giving the scene to Elnaz, I would like to know if I identified Elnaz and Mateus, but are there other presenter?
Hi, I'm here.
Okay. Who are you?
Elnaz?
Elnaz, okay. I just identified you. But I mean, there were 4 papers in the session, and I identify you and Mateus Braga, but for the other paper, since there are 2 people that entered without identification, are they involved in presentation? No? Okay. So please, Elnaz, the scene is yours, and the title of the paper is Evolutionary Approach of Clustering to Optimize Hydrological Simulations. Please.
Hi, everybody. My name is Elnaz Azmi from Karlsruhe Institute of Technology in Germany, and I'd like to welcome you to my presentation about evolutionary approach of clustering to optimize hydrological simulations. The motivation of this work is coming from hydrological simulations in high spatiotemporal resolution that help us to understand the nature of hydrological systems better. As you may know, simulation of such high-resolution models is compute-intensive.
Natale?
Sì?
We have lost Elnaz, I guess.
Yes.
In fact, I can't hear her.
Signal problem.
Elnaz, are you still there?
I guess no. It looks she's connected, but no panic. We have enough time.
Yeah. She's currently disconnected, yes. Waiting for her to go in again. Is there anyone else who can present her work?
Yeah, Mateus Braga is here. We can swap the presentation. Or wait just a few seconds, because, oh, it may happen.
Matthias, are you in?
Mateus here, yeah.
Yes, I'm here.
Ciao Ivan. Bene, sto coordinando una sessione, c'è un problema tecnico con la presentatrice, adesso vediamo. Sì, ci sentiamo dopo, ciao. Come? Ah, va bene, ok. Va bene, va bene. Va bene, ciao. We can wait till 10, 4 minutes more.
So we decided to wait. Osvaldo, I can't hear you.
Sorry, just a couple of minutes.
Yeah.
Mateus, can you prepare in the meantime? Podisho, are you... there is... I guess VK is another speaker. Mateus is not... Okay, it's ready. Okay. Mateus, can you... If you are ready, Mateus, we can start your presentation.
Good morning. Yes, I'm ready.
Hi. Okay, great. So Mateus Braga is presenting the paper, Attractive Arcade-Based Platform Approach to Exam Preparation. Please share your screen. difficult. It seems a problematic session.
Hello, Mr.
Okay, great.
Okay.
Please.
Okay, are you listening?
Yep.
Okay, good morning. Here in Brazil is 7 a.m. So I am Matheus from the Instituto Federal Catarinense, Santa Catarina, Brazil, and I introduce our work, attractive arcade-based platform approach to exam preparation. In this presentation, I'm going to talk about the introduction, related work, proposed approach, experiments and results, a conclusion, and the references. During the student school life has exams and tests, and the schools must prepare its students in many forms. Here in Brazil, one of these exams is the classification exam for Instituto Federal Catarinense, IFC, through a test to enter an institution. Encouraging the use of technology materials in the school environment can get the students' attention and be an effective way to archive the school's goals and objectives. And the school and teachers need to prepare different preparation alternatives for a good performance in this exam. And we can get the school can't ignore what's happening in the world and need to get some different alternatives to use in the classes beside the application of simulation and preparatory classes. Computer games and educational technology games have the potential to improve instruction. They stimulate and motivate individuals to perform tasks, behavior changes, and learning. They use mechanisms to encourage people to engage with them, often without any reward, just for the joy of playing and possibility to win. This is known as gamification. Gamification is a way of transforming school content in technology with the aim of stimulating and motivating individuals. And this approach aims to build an arcade machine platform with a game for solving questions and to collaborate with the divulgation of the institution, familiarizing students with exam template. Here on the left, we have a Mach 3 arcade game. And we get a lot of works that report the use of arcades as a form of entertainment which can attract attention. And some surveys, they try to use the arcade based on the education in the schools to try get attention and a new way to use the technology materials in the schools. One of these is the Tux Math, a game that with questions of arithmetic for learning mathematics, and a survey arcade-based with a quiz game integrated in the school, attracting a lot of attention from the students. So in the practice, use arcade-based can be assumed that they often and will give rise to playful behavior. This approach started with a questionnaire with 95 middle-level students on the Instituto Federal Catarinense in the first half of 2018, about period before joining on the EFC, to analyze efficiency of the institutional divulgation process and students' interest in use games for admission to EFC. As we can see, 89% answered that the divulgation could be better, isn't enough now. And 72% of the students said would use a game for admission to FC and maybe to prepare them for admission and the exam. So we asked the students about the method of preparation for the exam that they used, and 71% answered by reviewing exams from previous year on their own. So they get the tests, the exams, and try to do that in home. In this approach, we use the same way: get the previous exams and put it in the game in arcade-based platform. So this approach has two things: the game and arcade. The game is based in questions and answers proposed by the FC previous exams. The game was developed with Java language in the NetBeans IDE, MySQL database to store the information about the students, the questions, and the answers. And arcade was built with desktop machine, PC desktop, wooden structure, buttons, and joystick. So this is materials we used: a desktop machine, the wooden structure, and the buttons and joystick. So the desktop will turn on with the game in the desktop in the structure of the arcade platform. This is our game. So we have a home screen with two rankings, and after press some button, some in the structure, the student was going to the access screen to put his code. The code was chosen by the player and must contain 6 digits. After that, the students wait 5 seconds and get the question to answer. So he has the 5 options like the previous exams, and he gets the knowledge area of the question and the question on the center. This is our arcade platform. So we put this arcade machine in a municipal school, in the lobby of the municipal school at Sombrio during 11 days. And during this period, after viewing implanted, other users had interest in participating. We chose some users, the last users, almost going out of the school, and the students weren't forced or encouraged to use the platform. They played for their own interest, and we put the platform there, and they use it when they get. We had 47 registered players. 83% played at least once. 97% made more than one move. With the graphics, we can see that we have a lot of plays per day, getting the average of 23%. Yeah, 23 plays per day. And we have some days that is not so good. So we need to analyze that. And we have a lot of attempts and many kind of hits and misses. So we need to try to get how this influenced the students, and we can see that they had a lot of interest to use the the platform just to play, just to see how it was doing that. After the test period, a new questionnaire was performed with the students, and they choose more than one of the answers. We ask about the appearance of the Flip FC, if the Flip FC is a good preparation tool for study to enter in the EFC, and if they had some contact with the exam template, or if they had another form to see the tests and exams. And the 92% said the appearance is attractive. The Flip FC is a good preparation tool, 96%. 84% never had contact with the template exam. So these students saw the first time the template and known about the flips, the EFC by the platform. And another question asking how the game contribute to preparation for the admission exam. Almost 69% helped and gave them the opportunity to have contact with the exam question template, helping of any way prepared for it. Almost 14% helped to the game helped to train their knowledge for the exam. Maybe we can see the platform is a possible tool to use, considering as an additional tool in elementary education. Of course, we need to know that the Flip FC isn't to change another form, another method of preparation, but is alternative to help them to divulgate the institution and maybe help the students to know how is the exam and how is the institution and the materials they could see there. So educational game is already used as a strategy to help students difficulties improving performance and help them to construct knowledge. So we saw the platform was available to students and was not stable interest not only in using the game as a study, but also as entertainment, exercise their knowledge without realizing it. And as future perspective, develop an online tool, a mobile tool, to see the registering not new players, monitoring the activity of the players, and see the knowledge, the artist knowledge and the greatest difficulties. This is our reference. Thank you so much.
Thank you, Mateus. Any question? Can you detail a bit more the approach of gamification in what consisted? Because was a bit unclear to me. In which sense the student is involved in the game? It looks like you present questions and the responses, right?
Right.
So, which is the difference among this system, for example, and a web page where you notice question and responses, for example?
Okay. The students, our approach was based to put arcade based inside the school. So many students don't have internet in their home, they don't have mobile access. So we thought a way to put the questions, to put the exams, to put a structure maybe done on the FC. So we thought to put this thing on there, on the school, just to the students see that and maybe talk to oh, I can go to the school and maybe something like that. and they could see a tool like that, and they do something maybe equal, same.
Okay. Thank you. Now we have back Elnaz. So can you remove the sharing, Mateus? Okay. Elnaz, please. Can you restart? Great. Okay. We don't hear your voice.
Hi,
Okay.
everybody. Can you?
Great.
Okay, nice.
Great.
Hi,
Welcome back.
everybody. Sorry for the connection problem.
No
Hi,
problem. No
everybody.
problem.
My name is Elnaz Azmi from Karlsruhe Institute of Technology in Germany, and I'd like to welcome you to my presentation about evolutionary approach of clustering to optimize hydrological simulations. The motivation of this work is coming from hydrological simulations in higher spatiotemporal resolution that help us to understand the nature of hydrological systems better. As you may know, simulation of such high-resolution models is compute-intensive. One of the popular methods to tackle this issue is to use high-performance computing in order to process the hydrological model units in parallel. However, the parallelization of these models is challenging because of their heterogeneous nature and the demand of partially sequential execution of the model units. Also, parallelization requires programming expertise of domain scientists and revision of the existing codes. So here, I want to explain about our use case hydrological model that is applied on catchments. Functioning of catchments is controlled by a hierarchy of model units that the three main are elementary functional units, hill slope, and river element. I abstracted the model units into a network model to show the hierarchy and relations better. As you see, the objects or soil layers are in vertical containers or EFUs. Vertical containers are in the horizontal containers or hill slopes, which interact independently. Finally, all dynamics are collected in the collector points or river elements and produce the output of the model. According to the domain knowledge, dynamics of the simulation depend on the static properties and the current discharge of model units and the amount of rainfall enforced to the model units. The underlying principle is that similar properties, states, and forcings of the model units lead to similar simulation dynamics, which lead to redundancies that can be removed from the computation process. Our goal is to make use of redundancies in the simulated hydrological systems and reduce the computational costs of the simulation, also computing an approximation of the original model dynamics. Here you see a map of our use case that is Wolfsbach catchment in Luxembourg. In this work, we introduce an evolutionary approach to speed up the hydrological simulation. In the left diagram, you see a workflow of the original simulation showing the main loop. In the right diagram, you see the workflow of evolutionary approach integrated into the original simulation highlighted in green. The first block of the approach is added before the main loop, and the second block is inside the loop. In this approach, we avoid running the simulation for all hill slopes and reduce the computation time. In the next slides, I'll explain you these steps in detail. Initial clustering is a process of detecting similar hill slopes using their static properties like structure, size, soil profile, and drainage. For this purpose, we run a drainage test and extract 7 features from drainage time series that are the input data of clustering method. For clustering, we use the popular k-means method. And the main parameter for k-means is the number of clusters to be set. To determine an appropriate k, we use the popular elbow method and another method that we named it RMS EC time method. For more details, I would ask you to consult the paper. Every clustering is followed by the selection of representative hill slope of each cluster. We define the medoid of each cluster as representative hill slope and simulate only the processes of that hill slope. Then we map and scale the output of the representative hill slope to the member hill slopes of the same cluster. This way, we calculate the output for non-simulated hill slopes. To define the frequency of clustering during the simulation, we considered the intensity of the dynamics occurred. Since more dynamic processes run when there is forcing due to rainfall in the simulation, we run the clustering only by the active forcing time blocks shown in the left diagram. When forcing stops, we run the clustering once again at the beginning of the non-forcing time block. As we mentioned, dynamics of the simulation depend on the static properties, current discharge, and the amount of rainfall enforced to the hill slopes. In evolutionary clustering, while the simulation is running, we add two features, current discharge and flux, to our feature set. We define our evolutionary clustering as a clustering method that uses a new feature set dynamically during the simulation. In this case, we use again k-means clustering with an extended and updated feature set. We applied 3 test settings in order to test and evaluate the domain principles and to speed up a hydrological simulation. For constant K tests, we run the initial clustering only once at the beginning of the simulation, and during the simulation keep the representatives unchanged. This way, we don't apply the effect of dynamics in our clustering. For variable K tests, we run the whole workflow that we mentioned, including initial clustering at the beginning of the simulation and evolutionary clustering at each step of forcing time blocks, and once when forcing stops. In these tests, we continue the simulation with updated representatives. Auto K-tests use the same method as variable K-tests, with the difference that the K is using an automatic K determiner that we defined based on the elbow and RMS-EC time methods. They use evolving feature set generated by the dynamics during the simulation. Here, you see the simulation output of auto K-tests, the orange and blue curves, in comparison to the original simulation in black. KAEL is the auto K-test with the elbow method, and KARC is the test with RMS-EC time method. The trend of the curves fits well to the original, as you see. KARC shows a better fit in non-forcing time blocks. And the gray band represents 6 tests for KARC with different random seeds for k-means clustering. It becomes thinner in the forcing time blocks that shows a reproducible peak discharge. We evaluated the quality of our tests using RMS-E and their computational efficiency via speedup. As you see in this diagram, we summarize the evaluation of all tests. The original simulation is in the lower left, and the ideal area in this diagram would be the lower right. Our metrics show minor differences for the auto K and constant K tests. The additional clustering steps of the auto K tests result in a better RMS-E, but a lower speedup. Constant K tests showed the potential for a higher speedup, although the ideal choice for a high speedup together with a low RMS-E is unpredictable. Although K42 from a constant K test has the lowest RMS-E value of all tests, the prediction of such a favorable K without running tests for a particular use case is not possible. Therefore, we recommend KARC with a speedup of 1.8 that is close to half of the original simulation runtime, and it has an acceptable RMS-E value. With this, I come to the end of my presentation, and thank you for your attention. I'd be glad to hear your questions. Hi.
Sorry, Osvaldo, we can't hear you.
Oh, really?
Oh, sorry. Thank you, Elnaz. I mute my microphone. Sorry.
Okay, but could you hear the presentation?
Oh, yeah, of course.
Yeah.
Yes, of course.
Okay. Nice.
Very nice. Are there some questions? Can you return to the speed up plot
Yes, yes.
if possible, explaining
Yes.
a bit. Yeah, because it's not clear to me. Yeah, exactly. If you can describe better than which is the achieved speed up.
Yeah, here you
It's
see
on the
in this.
right part, or you mentioned it's an ideal, but I.
Yes, yes. So as you see here, in the left corner and the lower corner, you see the original that it has a speed up of 1 and RMSE 0. This is the
Okay.
original simulation. And the
Okay.
ideal case would be the lower right part, yeah? And
K9,
here,
you mean? K9?
yes. But
Okay.
but K9. So the thing is that we can't predict before using the tests that if K9 is the best or not. And K9 has more fluctuations than the others. So because of that, we use automatic K determiner to select an appropriate K. For
Okay.
this case, we are in the good range of a speed up that is 2 for with KARC and also KAEL. So with K42, we have a good and actually the best cases here K42 because it has low RMSE and also speed up is in good range. But we can't predict beforehand, and because of that we can use this automatic K determiner, and with that also we are in the good range.
Okay. Thank you so much.
You're welcome.
Other questions? Okay, so thank you, and that's very good presentation. Thank you. Vladimir, are you presenting the paper?
No.
Okay, sorry. I asked you because in the panel there were a paper from Marina Stankova, so
There should be a guy called Manchiang. Elena told me that he's.
Hello, can you hear me?
are you here?
Okay, I'm Mantianxiang. I should be the second presenter. I lost the connection for a few minutes, so I don't know what happened.
Okay, so the scene is yours.
Okay, thank you. So can I share my screen?
Oh, Elnats, can you remove the sharing?
Yes, I did.
Thank you.
Мама, люди как пахнет, эти девочки, неправда пахнут, мам.
Elnats, we have still your slides.
Okay.
Sorry.
Okay.
Mm-hmm.
So please.
Okay.
If you click on the upper right window, you can enter your name. Sorry.
Okay. I don't know how to do it.
Yeah, if you click on your window, where. Okay. You know how to share your presentation?
I should know it. Yes, it's here.
It's on the left-hand side, yeah.
Bottom.
Yeah.
So, can you see?
Yeah.
Can you see it? Okay, thank you. So, thank you everyone. My name is Man Tianxiang. I'm a PhD student in ITMO University in Russia. I'm glad to present my research in ICCSA. My topic is about domain-oriented multi-level ontology for adaptive data processing. As we know nowadays, data analysis is everywhere. It is a quite popular tool for our lives. So it's also a quite popular topic for the researchers. Now a large number of the data mining algorithms are existing, but the real life data are very complicated. So it has an obvious gap between research and application. So it is challenging to find the best solutions for specific tasks quickly. And we can't assume that all the data analysis researchers have enough experience and enough knowledge. There is a need to spot both experts and novices in their data analysis tasks. So we need intelligent discovery assistant. Meta-learning as a popular technique is used to improve the performance of the machine learning experiments. But our research is about semantic meta-meaning. Actually, they have the same purpose. It is to optimize the data meaning processes. There are some differences between meta-learning and semantic meta-meaning. Meta-learning methods are data-driven and work as a black box. But semantic meta-meaning is based on relative knowledge and internal relations. It complements the dataset description by in-depth analysis and characterizations of the algorithms. So here is the architecture of our research. In the core ontology, we enumerate the data characteristics in advance. Then we represent the definitions of the datasets and the tasks by merging domain ontology. Then we input our task requirements to extract the corresponding sub-ontology. In the sub-ontology, according to the data characteristics and task requirements, users can query and obtain the suitable solutions. But in this article, I will just show the design of the core ontology. We name it as DOMO. So DOMO is constructed with a multi-level structure, and the characteristics, the data characteristics and the task requirements are presented at the description level. They are the base for algorithm selection, and the components. And the components of the algorithms are presented at a process level. They are used to show the details of the algorithms. And as we know, the data mining algorithms have different performance in various situations. So at a characteristics level, we describe them as algorithm characteristics. Also, we describe data with data characteristics at this level, and then both of these two classes are linked by the property suitable for. Also, we link another DM ontology onto DM. It is used to show the implementation of the data mining algorithms. So, according to this idea, we built this core ontology. And the main structure is as the picture shown, and the construction of the ontology includes creating the input ontology. Also, we integrating some other existing data mining ontologies, for example, DMOP and OntoDM and DMWF. Here are the details of why we construct these ontologies. We create an input ontology as the input interface for the user query. It is used to define the data characteristics entities according to corresponding to the algorithm characteristics. and it describes the requirements of the data meaning tasks. That is the output of the data meaning algorithms. And to make the ontology adaptive, they present datasets in various domains. We use the OntoDT classes as the parameter.
We okay, now it's okay. Okay. We have lost the slides for a few seconds. Okay.
Okay. So to make it's okay. So to make the ontology adaptive, they present the datasets in different domains. We use the OntoDT classes as the parameters to specify the definitions of the data characteristics, and domain is first describe these concrete definitions in the ontology. Like the value, the range, something like that. And we also reconstructed some existing ontologies. For example, OntoDT is used for the up-level restriction for define the data characteristics, and some others like DMOP and OntoDM as the above I mentioned. And here, the main classes in the ontology, and we can see the classes here, and the annotations here, and also here is the main properties in the ontology, and there are many classes and properties, and if anyone interested in it, I think I can show you after the conference, or just check the article. So in this paper, we used the statistical ontology matrix from the software footage and the website bioportal, and the matrix includes, for example, the number of the axioms, the number of classes, the number of the properties, something like that. And here is a simple example how to use the ontology. We can see there when we input the concrete information about our dataset, then we can get the corresponding entities. In this example, we can see we input the number of the samples and time staple, and we can get the entities here. And here is the example of how should we curate in the ontology. For example, we can use it in the software footage. We input the characteristics, and we can get the result. The results are the suitable solutions. And because this example is a time series classification, time series dataset, so I use all the available time series classification algorithms to process this example dataset, and we can see the result. The average accuracy of the average accuracy of all the algorithms is 0.766 is here, and the average accuracy of the selected algorithms is 0.9. It is here. It is much better than another one. So here is the conclusions. We proposed domain-oriented multi-level ontology. We name it as DOMO. It is for data adaptive processing. The multi-level structure of the ontology includes the description level, process level, characteristics level, and implementation level. And the construction of the ontology includes creating the input ontology and integrating the existing data meaning ontologies. So I think that's all. And here is the email. If you have any questions, just send a message to me or just ask me now. So thank you.
Thank you. Thank you. Are there any questions? Can you please go back couple of slides where you present the results?
The results? Okay.
Yeah.
Okay, it is
Yeah,
here.
yeah. This is this slide exactly. Okay. Can you comment a bit more, because it looks like your algorithm has been tested only for a few cases, or which is the difference among the orange lines and the blue lines? Sorry.
Yes, yes, I understand it. Because I chose time series data set for this example, and we can see when query the ontology, and we get some more suitable because we showed the data characteristics of this example dataset, and here are the suitable solutions. It is a time series classification task. So here are all the available time series classification algorithms, and the blue lines are the algorithms which we selected, and we can see we selected 5. There are suitable solutions, and the others we didn't select them. And so here are the accuracy of all the available algorithms. Yes.
Okay. Okay. Thank you. Thank you so much.
Thank you very much.
Are there any other questions? Okay. I guess. Sorry.
Yes.
Thank you. You can
Thank you.
remove the sharing of.
Okay. Okay. Thank you very much.
Thank you so much. Is Mohammed Spy here? I haven't seen. So I guess we can close the session here. There is one presenter missing. Okay. Thanks a lot to everyone for coming. Bye bye.
Thank you. Bye.
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 Bye
Thank
bye.
you. Thank you very much.
Thank you.
Bye bye.
Thank you.
Good afternoon, everyone. We are about to start the next section of the General Track 5. I would like to ask if we have all the speakers connected already. So we have the first talk by Igor Enrique de Paula Barros Baeta. Okay, thank you. The second talk with many authors, Lucas Gabriel Felix and the others.
Hi, I'm here.
Hi, Lucas.
Hi.
The third talk by Renato Carauta Ribeiro and Edna Diaz Canedo.
I'm here.
Okay, thank you. Could you please set your name? If you press the 3 dots on the right bottom corner,
Okay.
and then you see the top menu item, and there you can set your name.
Okay.
Okay, thank you. And the last talk in the section by Dmitry Yashin, Vadim Moshkin, and Irina Moshkina. Do we have anyone? Not yet. Okay. So I would like to welcome the first talk, top-down parsing error correction applied to a part of speech tagging, Igor Henrique de Paula Barros Baeta. Welcome, so please share your screen.
Can you see the slide?
Yes.
Okay, can I begin?
Not yet, I cannot yet see it.
Oh, my connection is poor. Hi.
No, not yet. Yes, we can see it now.
Oh, yeah. Okay.
But it's falling apart.
Yeah, my connection is not very good.
Connection is very slow, probably.
Yeah.
What we can do, I can open the slides on my screen, but I need to have them.
Oh, you don't have
You
them?
share them on Riot, right?
Yeah.
On Riot. And then I will be showing. If you can remind me the.
It's 190 top down correction. My teacher that uploaded it.
Okay, 190, right?
Yes.
190.
I think so.
Okay, so unshare your screen, please. Stop sharing it, and I will share mine. Otherwise, we will.
I started it's just a connection ordinary.
Okay, let me. And you tell me, please, when to switch the slides, okay?
Okay. Okay, so I can see. Can everybody see it?
So I switch them. Can you see slides switching?
Yes.
I can see them.
Okay, good. Welcome.
So this is This is my presentation, top-down parsing and correction applied to part of speech tagging. You can go to the next one. Pass, please. We are doing a work with natural language processing. Natural language processing is growing in the community. It's undeniable. And while in English languages and English look-alike languages, similar languages to English, we have up to 97% accuracy in part of speech tagging and sentiment analysis and all NLP applications. And many other languages have not achieved that yet. Mainly languages that have many variations or languages that have a lot of different features. And Internet speak is one of these dialects. You see, pass the slide, please. And Portuguese has a lot of dialects, and it is spoken in 10 countries, 207 million speakers worldwide. And it has a complex grammar, but it's very structured, which makes it good to analyze based on a grammar, on a formal grammar. And another feature that makes it good for this application is it has a hierarchical construction of sentences. So we have orações, and these are made up of phrases that are made up of different kinds of this pieces. Can you pass, please? And so we decided to try to apply a top-down parser, normally found in compiler design. And they start from the root of the grammar and try to generate the target expression, creating a tree, a derivation tree. And by analyzing that derivation tree, we could then tag each word based on the steps that it took to generate. Not only that, but we could tag bigger structures, such as verbal sentences or other things like that. And for that, we needed to construct a formal grammar of Portuguese, and that was very hard. The first approach was building the grammar by hand, but quickly we discarded it as an impossible task, since Portuguese has complex and large grammar, and so we needed to find something to generate it from a corpus or from a text. So we found this algorithm, this paper that used genetic algorithms to induce a formal grammar, and we used it, but we modified it so that it used our first attempts to generate a formal grammar so that it could evolve faster, so that we could use the grammar quicker. And we also didn't aim for 100% accuracy to Portuguese. Since we were error correcting anyway, we could use about 95% and error correct most of the sentences that we found. So we generated the accuracy, we generated the grammar, and these are the 5 best populations. They quickly evolved, but they plateaued and started evolving very slowly. So we stopped it at 95% and kept going. Next. So to error correct, how do we do it? We first identify an error by looking where the derivation it's not correct. And we then modify the grammar by either via inserting a new symbol, removing a symbol, or replacing a symbol to force the derivation. And by that forcing, we can find what happened. If some word was inserted where it shouldn't, or some word was removed, or some word has a different tag, different part of speech tag in that place. Next. So what is part of speech tagging? Part of speech tagging is a process, is a step in classic NLP, and it's used to identify the sentence structure, its construction. So Mary ran every day. Then the part of speech tagger would classify Mary as a subject, ran as a verb, and every day as an object. So we do that and we correct that because of if the original tagger has some errors. Next. So to do that, we pick up a text, put it on the initial post tagger, and we pass this initial post tagging into an interpreter that we built that can interpret basically any formal grammar as a programming language or as something else. And we feed this interpreter with the Portuguese grammar so that in the end we have a better tagged sentence. Can you pass the slide? And so to test that, we use the Twitter corpus, and we took all the sentences from the World Cup, the 2014 World Cup, and we then applied the sentiment analysis algorithm and machine translation algorithm to that corpus. And for the sentiment analysis, we ran it before the correction and after the correction. And with the correction, we got a 3% accuracy gain. Before it was tagging with a 91.57 average accuracy, and we jumped it up to 94%. But the biggest impact was on machine translation. The sentence, esse Brasil vai me faca do coração, was before translated with the emoji on the same place it was before, because the translation algorithm could not handle the emoji. But now we identify what the emoji is meaning. In this case, it's the verb of the phrase. We substituted for a verb. We made a table of all emoji in all places. Then we translate it and substitute it back. So now the sentence makes sense, even if we translate it to a language that does not hold word order. Next. Thanks. Any questions?
Thank you. So please, questions?
May I ask question?
Yes, please.
May I ask question? Oh.
Yes, sure.
Yes. Do you hear me?
Yes.
Oh, okay. Sorry, maybe I don't listen you from the very beginning, but why are you don't satisfied with the methods of error corrections, previous methods of error corrections?
Mainly, we were not satisfied with them applied to Portuguese specifically. It's something that most methods are bound to a language. In the full paper, we compare it to the Hampos It's a trigram tagger, and we got not a better result, but a more consistent result using our method.
Thank you.
Are there more questions? If not, then thank you.
Thank you.
We are moving on to the next talk. Let me turn it off. Okay. So the next talk by Lucas Felix, forecasting soccer market tendencies using link prediction. Yes, welcome.
Hi, can you see my screen?
Yes.
Yes.
Hi, my name is Lucas Felix, and today I'm gonna be presenting the work forecasting soccer market tendencies using link prediction. Soccer is currently the most popular sport in the world, and due to its popularity, it generates an enormous financial flow due several ways, as marketing, merchandising, ticket sales, and player transfers. As an example, only in season 2016-2017, soccer has moved about 25 billion euros, and player transfers has represented about 5% of this total. And however, defining the price of a player is very difficult due the many aspects that have to be considered as players' ability, marketing, and performance in competitions. When considering performance in competitions, we have the FIFA World Cup as the main competition in soccer, and one of the most influential in the players' value. So, given these facts, our work aims to analyze the impact of the World Cup and study a property network of player transfers. We select countries that are present in the World Cups, and we apply a complex networks methodology composed by link prediction, centrality, and community detection. So stepping up to our methodology, we first gather data from transfer market, which is a huge soccer data set. And then we collect data from the period of 1962 to 2017. And we group this data in periods of 4 years, which represent the time between one World Cup and another. After gather all this data and group them, we model this data as a graph, considering as vectors the countries and the connections between these vectors, the transfers between one country and another. So basically, our methodology is composed by link prediction, community detection, and centrality, as we speak. In link prediction, we aim to predict future connections between the nodes. In community detection, we aim to identify similar groups of nodes within the network. In centrality, we aim to identify the main vertex in our graph. Passing to our results, we have that first we had to establish the best initial year to make our analysis and compose the 2022 network. So we select as the best year 2002 due the trade-off between the amount of vertex and the amount of network and the amount of networks. After establishing the 2002 as the initial year, we had to define the best threshold in the link prediction algorithm. And to define that, we established that the current year is the main network, and our predicted network will be the falling network. So if we are in the year of 2010, the year 2014 will be the ground truth year. So by that, we measure the accuracy and define the best threshold giving this information. After modeling our network, we pass to the application of algorithms over this network. First, we apply centrality, and then we apply community detection. Through centrality, it was possible to identify the main countries in the soccer market. We identify the so-called Big Five leagues, which are the big European countries in soccer. To consider farm markets, which are Argentina and Brazil, which sell players to these big countries. And the most interesting thing is the presence of China within these main countries, which shows the presence of the Asian countries in the market, in the soccer market, which has increased in the last years. Passing to our community detection, it was possible to identify within the groups a pattern composed by a huge country, a huge buyer country from the Big Five leagues, and smaller countries which play a role for supplying players to these big countries. Passing up to our conclusion, it was possible to identify that rich countries are easily connected with other countries, give their power, the money power, and within the communities, it was possible to identify a high variation, given that this works. These communities have countries that play different roles within the soccer market. As future works, we intend to expand the amount of collected data and test another techniques in link prediction, community detection, and centrality. Thank you.
Thank you. Please, questions?
Maybe me. Do you hear me?
Yes, we can hear you. Welcome.
Okay. I would like to ask you a question, very provocative question, but I am interested in it. Why do you exclude Russia from the list of the countries? Because to my mind, I'm not very experienced in soccer, but I think that we have, Russian football clubs have bought a lot of players. So to my mind, we are a rather rich country to buy soccer players, and you exclude Russia from your consideration.
I'm sorry, but Russia was not excluded. As we can see through the figure, is only the top 10 countries, and Russia was not in the top 10. countries.
Okay. Mhm. Thank you.
Are there more questions? I have a small question. So can you say if global events like the current pandemic influences the soccer market significantly, and can your methodology react to it?
Currently, our methodology cannot react to it. This work was developed before the pandemic. So, however, the soccer market is suffering with this pandemic. The price of player is decreasing drastically. Because with bigger problems, no one want to expand to buy players for a huge amount of money. So we have a effect in that way. I don't know if I answer your question.
Oh yes. So in the
Okay.
current state, the methodology would not give the correct prediction results. So you have to think how can you, well, you cannot predict these black swans, basically.
But if we gather data from 2019 and 2018, it was possible to model better the impacts of the impacts of the pandemics. However, our data only goes to 2017. So if we could gather more data, possibly we could see an impact of the pandemic's overall network.
So maybe you'll do it in your future work.
It's a good idea.
Okay, are there more questions? If not, then thank you again. And we welcome our next speakers, our next talk on digital signature in the ICCSA standard as a REST service.
I'm here. I'll share
Yes, Renato.
Yes, I'll
Please.
share my presentation.
We cannot see it yet. Now we can see it, yes.
You can see? Okay.
Yes.
Yes, we can see it full screen now. Thank you.
Okay, and start. My presentation is about digital signature in the shared standards as a REST services. Is a use case University of Brazilian. This is the plan of the presentation, introduction, background, contextualization, and conclusion. The introduction, the information security is a widely topic by several countries that have to create increasingly stringent laws to protect the security information. This topic aims to protect reliability, integrity, availability of information, wherein the storage, process, and transmission of data. Some laws created by talking about the personal data and the security were created in many countries. One of the most important international laws is the General Data Protection Regulation, GDPR. The GDPR protects the laws since the data is created until the data is discarded. And in August 14, 2008, Brazil approved the Brazilian General Data Protection Law. This law is based on GDPRs and provides the security data of personal data, including digital medias. It is like GDPR, it protects the data since the data is created until the data is discarded. One of the essential processes this law talking is how to share this data in security way. Is used the encryption. There's two ways to encrypt the data safely. One is using symmetric encryption, and the other uses asymmetric encryption. The Brazil, the Ministry of Education, MEC, established the university degrees of the Federal Education Institute must be emitted these university degrees in a digital format using the SHAD's partner. The main authority of the the certification is ICP Brazil. The ICP Brazil is certified this signature is valid in Brazil. This work tried to develop a new digital solution for focus on microservice architecture to ensure greater scalability and fault tolerance, and a good security for the university degrees in University of Brasília. The symmetric encryption is the first type of encryption created by humanity, and it does work like this. The transmitter sends the clear text using the shared secret keys to cipher this information, send the cipher tasks in a non-security channel like internet. The receiver receives this information, decipher this information using the same secret keys, and it can read the clear text. One of the main problems of this type of encryption is you have to share the secret keys in a security channel, and they stay the secret key security. If not stay the security key security and not share the in a security channel, this method is not secure. For solve this problem is Diffie-Hellman created the asymmetric encryption. He used the two independent keys, one for encryption and other for decryption, and they had two essential characteristics. Is computationally unable to determine the decryption keys given only the knowledge of the encryption algorithm and the encryption key. And either one of the two keys can be encryption or decryption this information. This the picture of how this work. The transmitter send the clear text. They can cipher this text to use the public key and the algorithm for encryption, or the private key, but in the example, use the public key for cipher this information, send this information. The cipher text is in a channel. The receiver receives this information, decipher this information using the private key, and can read this text. The public key you can share on the internet with no problems. The private key you never share on the internet. You can maintain this key's security. For the asymmetric encryption has a problem because you don't know if the asymmetric these keys is really a security keys or not. For solve this problem is you have two digital signature. The digital signature is a third party to sign these keys, and he's guaranteed these keys is authentic and security. The contextualization about the university degrees, né? The federal government provides various services digitally, like in educational art, like university degrees, the historic of the students, and the others important information. This information has to be cryptographed and has to be security. And the Ministry of Education created two ordinances. These regulations for university degrees in digital format. The first ordinance created by MEC is the number 330 in 2018. This ordinance established the digital university degrees. They authorized the university emit these diplomas in digital format. And the other ordinance created is 554 in 2019. Specifies what is a digital diploma is, what pattern is this use, who can sign this diploma, who authorizes can sign this diploma, this university degree, and it has more specific. This ordinance is more specific than the other ordinance. They said the shared pattern that is used for signing the university degrees. And these university degrees must be done in a computational environment that guarantee validate to any time, interoperability between systems, security technology to update, and the possible to multi-signature on the same university degree. According to MEC, the MEC established that all university degrees must be in XML and signed based on shared pattern. The actual architecture Universidade of Brasília is based on domain-driven design. The main concepts of the domain-driven design is to subdivide a large business domain into a smaller domains, like microservices. The actual architecture in University of Brasília is communication between front-end developed by Angular, communicate with the back-end developed by Java, intermediate with the service bus developed in Erlang language. That's communicate between front-end and back-end services. Some modules in the service bus, some services is the communication REST between front-end and back-end, the authentication module in LDAP protocol format, and the authentication in OAuth2 protocol format. In the future, this work tries to create a module for signing the university degrees and the other documents in SHADE's pattern. How this work, the communication between front-end and this service bus developed by Erlang language. The front-end call with REST protocol. The service bus catch this with a dispatcher, and this dispatcher call the specific service the front-end calls. The service processes this operation, and the service returns the results. The REST communication, like I said, between the service and the front end and the back end is a 12 microservice. This article aims to the base architecture model for signing digital documents and diplomas in SHADE's pattern. For doing this, it is important to have a XML university degrees, complex in zip format, and you have to sign this XML using A3 certification. For doing this, you have to need the HTTP post by, for example, like /certification, /document, /sign URL. And the payload is the zip file in the XML zip file and the certification. You call this service, and the service must be returned the URL, sign the diploma in the SHADE partner. The module of certification has three main modules. The primary module is the crypto sign. This is the main module for signing these documents in SHADE partners. These modules has all methods for signing these documents and for conversion the UTF-8 to a canonical format and the other things. The crypto util is a module for util methods for open this document, open the certification, and the other methods to help the method for signing. And the crypto validator is the method to check if the university degree signing in the correct SHADE partner they have all tags the MAC intend to be in the XML documents. And the conclusion of this work is in the Brazil, the actual government has to be digitalize many documents in areas of education, university degrees, school histories, declaration of active students, and the others. This work presents central norms of the requirements for the creation solutions, signed documents, university degrees in the digital formats. And this work trying to create a new solution, a minimal solution for signed documents in the digital format, with the norms of MAX and the norms of ICCSA Brazil 2. And for future work, it's really important to compare the actual security format SHADE's partner with other partners like SCADs and PADs, and try to compare if this is the best way to sign these documents, is the PADs is more secure than the SHADE's partners. Try to, in the future work, is the MAC doing a better way to sign the documents, and so on. And that's it for my presentation. If you have any questions or remarks, thanks.
Thank you, Renato. So please, questions?
Maybe I have the small one question. Have you considered using the distributed ledger technologies, the blockchain concept, in your work, in your research?
Because the University of Brasilia use this safety bus developed by Erlang, I'm trying to develop using microservices. I don't think about the blockchain and the other type of certification because the ICP Brasil and MEC try to really focus on using this partner, and I don't have much other choice to use other partners or something like this. But I don't think they use blockchain and other kinds of types of encryption. I don't think this.
Okay, thank you.
Are there more questions?
I I can ask question about the public key. Please, it's general, somehow general question. What information could you could you obtain from the public key?
The information can obtain for the
So,
public key. Wow.
yes, because you encrypt you sign by digital signature, and then you can what you can do with the public key.
Well,
Can
the
you
public
obtain all the information about the student, the year of his graduation, and so on?
okay, understand. You have the history of the the how history of the education the education try to obtain the university degrees. You have the our notes and have other things. The just have the like me said, just have the history of the all disciplines and the grades of the all disciplines, and that's the main things of in the public in the future certification.
And is this information open? So if you have public key, you will obtain all information concerning the student.
Yes,
And
this information is open for the yes.
okay,
It's made to be open for the student. Yeah.
thank you.
And I have a small question. So does this mean that your service becomes the central part and all the documents should be signed by it? Or is it a set of services, some distributed network, and all of them can sign these documents?
Okay, can you repeat, please? I can understand this.
So you have a service that creates the signatures, right?
Yes.
So is it the only service in Brazil? Like
No,
the
it's not.
you have
It's not
many?
the only service in Brazil. There are other universities try to do the other solution for signing
So
these documents.
your service signs the document for particular university only.
Yes, it's for
Only
particular
one
university.
Okay.
Yes, I try to do this search for a main search for other university to use, but this work is only for University of Brazil. In the future, I try to develop this for the other universities.
Mm-hmm. And can you estimate the workload? So can it become a bottleneck? So how many documents it signs? How often it happens?
At the University of Brasilia, sign like for 10,000 university degrees in 10,000 to 3,000 university degrees every year, and this is my solution have to do sign this quantity of the university degrees every year.
So the performance is enough. So your service can cope with this.
Yes. The language Erlang, like I said, the service bus developed by Erlang, and my solution developed inside the service bus, and the language Erlang can assign this quickly.
Okay. Thank you. Are there more questions? If not, then thank you, Renato, again. And let's move on to the next speaker. And we have the last talk, an approach to the selection of a time series analysis method using a neural network by Dmitry Yashin, Vadim Moshkin, and Irina Moshkina. Do we have any of the speakers present? Doesn't seem so, unfortunately. So apparently we have to finish our section now, because we don't have the talks.
Okay.
Okay, thank you for participating, and see you in the next general track section. Or first, don't forget about the plenary talk, which will happen, I think, at 2 or 2:30 o'clock. We have to consult the schedule. So
Thank you.
Thank you for participation. Bye-bye.
Goodbye.